Welcome in the class of design of steel structure. We are learning the design of column bases. So far we have learned slab base, gusseted base. In this lecture we are going to see the grillage foundation. So I am Mr. S. S. Sogule, Assistant Professor, Civil Engineering Department. So grillage foundation is essentially consists of the steel beams encased in the concrete. It may be provided when the loads on the column are extremely heavy, that is tall buildings. The base plate is required in such case will be very large and dimensions and this is not feasible in this case. Second thing is when the bearing capacity of soil on the which the concrete block is placed is very poor, which results in the large dimensions of the concrete pedestal and the base plate. The column in such cases placed over the base plate, which in turn supported over two or more tiers of the beams, and the whole thing is encased in the concrete. The successive tiers of the beam run into the right angles to each other, and the concrete in grillage foundation checks the buckling of the beam as the grillage beams are encased in the concrete. So most of the requirements of the encased beam are applied to the them. As per IS 800, the following condition must be fulfilled. The beam should be unpainted and solidly encased in the concrete with 10 mm aggregate and a working cube strength not less than 15 Newton per mm square for 28 days. These are never painted as painted beams do not bond with the concrete. The beams in each tier are placed such that the minimum spacing between the flanges of two consecutive beams not less than 75 mm. The pipe separators are provided to maintain the proper spacing between beams. This is done to place and compact the concrete properly. Third thing is a concrete cover of minimum 100 mm is provided around the beam tier arrangement. The size of base plate is independent of the bearing capacity of the concrete block since it is raised directly on the upper tier of the beams, while thickness of the base plate should be sufficient to check punching. Its width should cover the upper tier of beam completely. The length of the base plate is proportional to the base connection of the column. The number of upper tier beams depend upon the width of the base plate and fewer beams can be accommodated. The beam section design are quite will be quite deep. The length of the upper tier beams depend upon the number of beams to be provided in the lower tier and this in turn depend upon the unit pressure from the foundation and the clearance between the consecutive beams. So some assumptions are there. The load from the column is uniformly distributed over the base plate. Then second is each tier of the beam distributes the load uniformly over the lower tier and intensity of bearing pressure is uniform. So as here you can see, this is the arrangement for the grillage foundation. So this is the lower tier beams and this is the upper tier beams. The base plate has been placed over and column is placed on the base plate. So this entire assembly is encased in the concrete. So this is the top view and this is the side view. Now what are the design forces? So P is the load on the column, A and B are the length and width of the base plate, L is the length of the upper tier beams and B is the length of the lower tier beams. The load distribution from the column on the base plate and the upper tier beams section is shown in this figure. The shear in the beam is 0 at its ends and at the center. The maximum shear occur at the edge of the base plate. So here you can see this is the maximum shear and this is the BMD which is maximum at the midspan. Now the load per unit length of the beam is P by L. Maximum shear force is P by L into L minus A divided by 2. So this is lower tier beam and this is P by L, that is force divided spread on that particular area, and the maximum shear force that is at these locations, so that is P by L into bracket L minus A divided by 2. Similarly, on the other side, that is P by 2 into L by A, and L minus A divided by L, and on the other side this P by 2, that is shear is P by 2, B minus B divided by B. So bending moment at the beam is 0 at the ends and maximum at the center. So again for M, that is P by 2 into L by 4 minus P by 2 into A by 4. If you analyze the beam by using SFD-VMD method, then it further modified, that is P by 2 into bracket L minus 4 divided by A by 4. Further it is P by 8 into L minus A, and on the other hand it is M is equals to P by 8 into B minus B. So now the design. As per IS 800, the allowable bending stress on grillage beams encased in concrete may be increased by 33.3%. First step is the compute the design load and the size of the footing. Let load over the column, add 10% of the column load to the load P in account to dead load of the column and the grillage. The area of the grillage footing is computed. Divide the design load by bearing pressure on the concrete. Provide a square or rectangular footing as in case may be for the base plate. Calculate the maximum bending moment for upper tier beams from the this equation, that is this for the upper tier, this is for the lower. The allowable bending stress as per IS, that is 1.33 into 165, that is for FY 250 MPa. Compute the section modulus and number of beams provided into the upper tier. Choose the section from the steel table. Then calculate the maximum shear, that is V equals to 1 by N P by 2 into L minus A divided by L, where is L is the N is the number of beams in the upper tier. And check the beam section for shear and the crippling. Calculate the maximum bending moment again for the lower tier. Then compute the section modulus and select the number of beams and provide it into the lower tier. Calculate the maximum shear, that is 1 by N E by 2 B minus B divided by B, where N is again number of beam in lower tier. Check the beam section for shear and the crippling. Now we will see the problem. So design the two-tier grillage foundation to carry an axial load of 1000 kN. A base plate is of 700 by 700 mm is provided below the column. The concrete is of M15 grade and bearing capacity of the earth is limited to 150 kN per mm square. Now the axial load is 1000 kN. We are adding this 10% by multiplying it by 1.1. So that becomes 1100 kN. Now required area for the grillage foundation is 1100 divided by 150, that is 7.33 meter square. We are providing 7.4 meter square. So provide a square shape base. So side of the base is square root of this 7.4. So that becomes 2720.29 mm. So we are providing 2800 mm. So provide a base of 2.8 by 2.8 meter. Now the upper tier beams, so maximum bending moment, that is P by 8 into L minus A. So P is 1000 divided by 8 into this 2800 L, and this A is 700. So that becomes 262.5 into 10 raised to 6 Newton per 6 Newton mm. Now all the beams are encased in concrete. The allowable bending stress increased by 33.3. So sigma BT calculated is 0.66 Fy into 1.33. So 0.66 into Fy into 1.33, that becomes 219.45. So Z required is 262.262.500 into 10 raised to 3 divided by 219. So that becomes 1196.172 into 10 raised to 3 mm cube. So clear spacing we are providing 75 mm. So we have to select 4 ISMB 225 from the steel table. So the properties has been given over here. So B is 1100, T is thickness is 6.5, H2 25.85, and Z is 305.9. So clear spacing between flanges, that is 700 minus 4 into 1100 divided by 3. So that becomes 86.67, so which is greater than 75, hence it is okay. Then the maximum shear force, we have the formula, so that becomes 93.75. So tau VA calculated V by dt, that is 93.75 into 10 raised to divided by 225, that is depth, and 6.5 is the thickness of the web. So that is 64.11, which is lesser than 100, hence it is okay. Now check for the crippling. So sigma phi calculated divided equals to P divided by N into bracket A plus 2 under root 3 H2 into T, where A is the length of the base plate. So 1000 divided by 4 into bracket 400 plus 2 into under root 3 into 25.82, that is H2, into 6.5, that is T. So that becomes 48.726, which is lesser than 187.5, hence it is okay. Now lower tire beams. So maximum bending moment P by 8 into B minus B. So again P by 8,000 divided by 8 into 2800 minus 700. So that becomes 262.5 into 10 raised to 6. So Z required is 262.5 into 10 raised to 6 divided by 219, 145. So that becomes 1196. So we are providing ISLB 175. So width of the flange is 90, thickness of the web 5.1, H2 is given 16.7, and Z-axis is 125.3 into 10 raised to 3. So clear spacing, that is 1 by 9 into bracket 2800 minus 19 to 10, so that becomes 211, which is greater than 75 mm, hence it is okay. So the section modulus provided, that is 10 into 125. We are providing the 10 numbers of beams, so that becomes 1253 into 10 raised to 3, which is greater than 1196, what we required, hence it is okay. Then for checking for shear, the shear is 37.5 into 10 raised to 3. So this V divided by dt, that becomes 42.01, which is again lesser than 100, hence it is okay. Again check for the crippling, the load divided by this 10 into bracket 700 plus 2 under root 3, 16.7 into 5.1, so that becomes 25.875, which is lesser than 187.5, hence it is safe. So this is designed for the grillage foundation, hence it is okay. So this is all for today's lecture. Thank you.